Hello class, welcome to another chapter by Professor Choi. Today the lesson is about elasticity and the responsiveness of supply and demand. So what exactly is elasticity? Elasticity is basically a measure of how much one economic variable responds to changes in another economic variable. One of the best ways to visualize elasticity is to think about a supply and demand model. So when we were covering our supply and demand model, normally when a professor is drawing it for you, what you get is you get these sort of straight lines that look like that. Now, one of the things that we don't tell you at the time when they're explaining, when we're explaining the basic supply and demand model, is that the lines don't have to look like that. They could be steeper, for example, in the case of the demand line, or they could be flatter, or they could be even more flat. And what I mean by flat is, if you think about this as being like somebody walking up the mountain, then this is a pretty steep mountain, and this is a pretty flat hill. Okay, so elasticity is basically the relationship between price and quantity in the case of demand, or whatever two variables you wish to create a relationship for. Now, when the line is more steep, in the case of this line, so if the line happens to be more steep, then we call that inelastic. So the steeper the line, the more inelastic it is. And then the flatter the line, and again, think about that as being like somebody walking up the hill. So this is kind of like a low hill. It's like a steep mountain. All right. So the flatter it is, then the flatter the line is, the more elastic the line is. So a flatter line is relatively more elastic than a steeper line. And elasticity is sort of relative, because if you look at the line in the center is more elastic than the line here, but it is also more inelastic than this flatter line. Okay? So basically, the steeper the line, the more inelastic, the flatter the line, the more elastic it would be in general. Now, if you actually take the elasticity at different points on a straight line, you will notice that elasticity changes along the line. So basically, if you were to kind of calculate elasticity around the center of the line, then it will be what we call unit elastic, or unitary, some books call it. While if you're down here, it will normally be more, if you're down here, it will be more inelastic. So in other words, if you were to calculate elasticity around these points, there will be more inelastic. And if you were to calculate elasticity around these points, there will be more elastic. So elasticity actually changes along a straight line. So we can't really say that a straight line has a one elasticity, because what it does have is one slope, but elasticity is different than a slope. Now we can definitely say that a flatter line is in general more elastic than a steeper line. All right, now how does that change anything? Like, what does it matter? Well, I want you to think about a particular price and how quickly it changes. Oil, for example, it's renowned for having prices that are really high and then very low, all of it very quickly. And one of the major reasons for that is because the supply of oil is highly inelastic, while the demand for oil is also highly inelastic. Now, let's just take a look at an inelastic supply, just as an example, paired with a kind of like normal looking demand. So if we move, say, the demand to the right, notice that as we're moving from this point to this point, the movement along price, so the price movement that you're going to see from point 1 to point 2 is more than the quantity movement that you are going to see. So the amount of quantity change is smaller than the amount of price change. And this is given by the inelasticity of the supply line. So another way of thinking about elasticity is when the percentage change, and that triangle is the letter delta, which means the change. So if I say, for example, delta x, that's the same thing as saying x2 minus x1. So it's the difference or the change between the two. So the percentage change in price is greater than the percentage change in quantity, is another way to describe what an inelastic line is, or what an inelastic product is. A more elastic product, the percentage change in price will be less than the percentage change in quantity. And again, this will be more elastic. Okay? And if it's unit elastic or unitary, then the two are the same. So percentage change in price equals the percentage change in quantity. And this is what we call unit elastic or some books call it unitary. All right, so let's keep going on elasticity. Now we're going to study, in this case, 4 types of elasticity, and we're going to start with elasticity of demand. So price elasticity of demand is basically the responsiveness of the quantity demanded to a change in price, measured by dividing the percentage change in quantity demanded of a product by the percentage change in the product price. So the basic elasticity formula is percentage change in quantity demanded divided by percentage change in price, in the case of price elasticity. So let's come up with an example for that. So let's say the price of kaputs, and kaputs is a made-up product, by the way, just made it up right now for the purpose of the example. So let's say the price of kaputs increases by 14%, and as that happens, the quantity demanded decrease by 10%. What is the elasticity of demand? All right, notice a couple of things here. First, when you're talking about elasticity of demand, there has to be a negative relationship between prices and quantity demand. And the reason for that is because the demand line is a downward sloping line, or it represents a negative relationship between prices and quantities. So every time you see prices go up or increase, you're going to see quantities decline, as you can see here. So as prices go, demand line. So as prices go up from this point, call it 1, to this point, call it 2, the prices increase along the demand line as the quantity demanded decreases. Alright, so the point that I was trying to make is that every time you're calculating elasticity of demand, you should expect a negative relationship between the two. So when prices increase, you need to see quantities decrease because the demand line is downward sloping, and if you were to pick a point on another point on the demand line, you're going to notice that if we move from say 0.1 to 0.2, when prices increase, the quantity demanded decreases. Okay, so how do we find the elasticity of demand in this particular case? Well, elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. So if my percentage change in quantity demanded is 10%, notice that it is a 10% decrease, so it's negative. And my percentage change in price is 14% higher, then my elasticity will be 10 divided by 14. Or it will be negative 0.71. Alright, and that's my elasticity of demand. Alright, now because this class is developed for college level, we have to make it a little harder, and we have to teach you the best formula for elasticity. The best formula for elasticity is what we call the midpoint formula. The midpoint formula utilizes the midpoint between two points, or it uses the average between 2 points instead of using the individual point for the denominator. So one way to calculate elasticity is to just use percentage changes. So you would use percentage change in quantity demanded, and one way to do that is just to do Q2 minus Q1 over Q1, and this is normally the approach that you use in a sort of high school class. It's just faster, but it is not the best. The best way to calculate elasticity is to use what we call the midpoint formula, and the midpoint formula, what it basically does is it uses Q2 minus Q1 for the top, but then for the bottom it uses the average. So it uses Q2 plus Q1 over 2. And that becomes percentage change in quantity demand. Okay? So the elasticity of demand will be percentage change in quantity demanded at the top using the midpoint formula divided by percentage change in price using the midpoint formula. And again, the difference is we use the average on the denominator. All right, so let's come up with an example where this might be useful. Now I want you to think about applications of this, by the way. So imagine you own a store and you decided to increase the price of kaputs from $10 each to $15 each. All right. Now, of course, every time the price of a product goes up, less people are going to buy it. So afterwards, you'll notice that quantity demanded declined from 1,500 units sold to 1,400 units sold. So I got 3 questions for you. First question is, calculate elasticity of demand. Second question is it elastic or inelastic? And the third question is, which of the two prices will make you more money? Price of 10 or price of 15? Okay, so let's try to figure this out. Alright, so to calculate elasticity of demand, I got to remember my formula. So elasticity of demand is going to be equal to percentage change in quantity demanded. So that's going to be Q2 minus Q1, and then Q2 plus Q1 divided by 2. Then I gotta do my percentage change in price. So I gotta do P2 minus P1, and then P2 plus P1 divided by 2. Alright, so that's my setup for elasticity using the midpoint formula. Now you need to kind of label these. So if you decide to use the first one as your P1, then you have to make sure that you use the first one as your quantity 1, because this price is associated with this quantity of units sold, and the second price is associated with the second quantity of units sold. So over here, we're going to use P1, our first price, and then P2, our second price, and then we're going to use Q1, our first quantity, and Q2, our second quantity. Alright, so now we're going to plug them into our formula. So Q2 is going to be 1400, and then minus Q1, 1500. We're going to divide that by Q2 plus Q1, so we're going to do 1400 plus 1500. And then we're going to take all of that and divide it by 2. Okay. Then we're going to take our prices. We're going to take P2, which is the second price. So that's going to be 15. And we're going to subtract our first price. That's 10. And then we're going to do P2, which is the second price. So 15. We're going to add the first price. And we're going to divide that by 2. And that's our average. So we're doing our difference divided by average, difference divided by average. Alright? If you're not very good at math, by the way, don't try to plug in all that stuff right away. You need to be a bracket master on your calculator to be able to do that. So it's easier to just kind of like do each bracket individually. So we just do this right here. So that's minus 100, negative 100, sorry. And then right here we have kind of like the midpoint between these two numbers, so that's going to be 1450. Okay. Alright, so again, what we just did is I solved this bracket here, and that's 1450. I solved this bracket at the top, and that's negative 100. Then I'm going to solve this bracket here, and that's going to be 5. And then I'm going to solve this bracket down here, and that's going to give me 12.5. Okay, so I'm just making it easier for me to calculate. Then I got to do this portion here. Alright, then plug it into my trusty calculator. So you do 100 divided by 1450, and that's going to give you negative 0.0689. Oh boy, I got to round up here. Okay, 7. Alright, and I'm going to divide that by whatever this gives me. So that's 5 divided by 12.5, and that gives me 0.4. So now I gotta solve this one here, and that gives me 0.06897 divided by 0.4. That gives me negative 0.17. All right. Oh, did I set 7 and wrote 4? Yes, I did. All right. So fix that. 0.7. Okay. This is my elasticity of demand for the example that we have here. All right. So how do we figure out? So I calculated my elasticity. How do we figure out if it's elastic or inelastic? Well, if you come to my PowerPoint, I tell you right here. Now, to figure that out, you got to take the absolute value. Okay? So, the absolute value is basically the positive of whatever number you have. Because remember what an absolute value is. The absolute value is the distance between 0 and whatever number you have. So it's the absolute value, which is the distance. So if you're at, say, number 17, then the distance between 0 and 17 is 17. And if you go from 0 to negative 17, the distance is also 17, and that is my absolute value. So the absolute value of negative 0.17 is 0.17. All right. Now, once I've done that, it says here that if my elasticity is greater than 1, then we're going to call it elastic. If it's equal to 1, we're going to call it unit elastic. And if it's between 0 and 1, we're going to call it inelastic. So basically, this one is a number between 0 and 1, and therefore this is inelastic. All right, so let's take a look at the third question. Which of the two prices are going to make you more money? All right, now, if you look at my PowerPoint, I kind of already explained that. But before we get there, let's just think about this as a, I don't know, as a sort of accounting way of thinking about things. So you have two different price schemes. I could decide to charge more money and sell less, or I could decide to charge less money and sell more. Elasticity will tell me whether I should do scheme number 1 or scheme number 2. All right, so let's take a look at these price quantities that I have. If I were to use price 1 and quantity 1, my total revenue, or the amount of money that I'm going to be making from the sale of my kaputs, is going to be 10 times 1,500, or 15,000. So that's how much money I'm going to be making if I follow my first sort of price quantity strategy. All right, my second price quantity strategy, or total revenue 2, is equal to my second price times my second quantity. So I'm going to take my second price, which is 15, and I'm going to multiply that times my second quantity, which is 1,400. And again, notice that it is a lower quantity, but let's see if I make more money. Voila! If I do 15 times 1,400, I end up with 21,000. All right, so notice that my second price is better, and therefore that's the one I should be keeping. Now, why is this so? Why is it that if the price went up, I actually make more money? Well, that has to do with the fact that the product that I'm selling is inelastic. So inelastic products should never go on sale, because inelastic products don't move faster if the price goes down. They are inelastic. Prices that are products that are more elastic should go on sale, because when the price drops, people buy more. All right, so these right here are two extreme cases of elasticity. Perfectly inelastic basically means that the line is a straight vertical line. Perfectly elastic means that the line is a straight horizontal line. This right here is explaining a little bit about, again, how do you figure out whether something is elastic or inelastic. Remember, you have to use the absolute value to use this definition here. So using the absolute value of an elasticity, if it's greater than 1, you call it elastic. If it's equal to 1, we call it uninelastic, or some books call it unitary. And if it's between 0 and 1, we call it inelastic. Now, what are some of the determinants of elasticity? Well, one of the most important determinants is the ability of having other substitutes, other things that you could buy instead. So the more availability of substitutes, the more elastic a product becomes. The greater the passage of time, the more elastic the product becomes. The more you think of a product or a luxury versus a necessity. So if you think of something more of as a luxury, then it's more elastic. And if you think of something as being more of a necessity, then you think of it as more inelastic. Again, back to why this whole idea of elasticity matters. I'm a little older than most of my students. And one of the things I cannot fathom is how can some of my students say they don't have enough money for, say, books, but they can afford to buy a $1,300 phone. Okay? Now the reason for this, and again, I'm not criticizing anyone, the basic reason for this is because they think of their phones as a highly inelastic product. In other words, if you ask these students, do you think of your phone as a necessity or a luxury? A lot of them will actually tell you that their phone is a necessity. And they need it for this, and they need it for that, and they use it for this, and they use it for that. And when something is considered more of a necessity, it is also more inelastic. Now, when something is more inelastic, it also means that the price change can be done faster than the quantity changes. So in other words, as a manufacturer like Apple or maybe the upper end kind of Galaxy phones increase the price of their phones, you still buy about the same amount as before. So prices can move up much quicker, and the quantity dropped because of those prices is smaller, and that is an inelastic product. All right, so again, if you think of something as more of a necessity, then you're more inelastic. If you think of it as a luxury, you're more elastic. If you don't have a lot of substitutes, and again, I want you to think about somebody who just sort of used to using the iOS software in their iPhones, they are unwilling sometimes to switch to a different software simply because they don't want to do that. In other words, it takes too much time to learn the new software. That makes them that means that for them, there are no close substitutes or very few to what they have. The next one is the definition of the market. The narrower you define a particular market, the more elastic you become. The broader you define a market, the more inelastic you become. And this one right here is kind of like, imagine the difference between saying, I want Kellogg's for breakfast, which is a very specific thing. Now there's a lot of other substitutes to that, so you're more elastic when you're being very specific. But imagine that instead I would say I want cereal for breakfast. So I'm very broad because there's so many things that fit on my cereal category, then I will be more inelastic on the word cereal because there's a lot of things I could buy that would qualify as cereal, while I will be more elastic on the word Kellogg. So the more specific you define something, the more elastic you are. The broader you define something, the more inelastic you are. The last one is a share of the consumer's budget. So when something is a larger portion of your budget, then the more elastic you become. When something is a smaller portion of your budget, the more inelastic you become. All right, this slide we explain the relationship between total revenue and elasticity. So this is a relationship that would basically answer question 3 of any problem, if you remember the relationship. So which of the prices am I going to keep? It basically depends on elasticity. Okay, so if a product is elastic, as the price increases, the total revenue tends to decrease, and as the price decreases, the total revenue tends to increase. So if you have, let's say, elastic product, then you want your price to go down so your total revenue goes up. Instead, if you have an inelastic product, as the price increases, the total revenue increases. So you make more money as the price goes up if the product is inelastic. If the product is elastic, you make more money as the price goes down. If the product is unit elastic, then price doesn't really change revenue. All right, let's talk about the second elasticity. This elasticity is what we call cross-price elasticity of demand. And in this one, we're looking at a percentage change in quantity demanded of one good, and how does that compare to the price of another good. So cross-price elasticity uses two different goods. All right, so we have, in this case, the percentage change in quantity demanded of good A compared to the price of good B. All right, let's come up with an example for that. All right, so let's say when the price of kaputs increases from, let's say, 12 to 14, the quantity demanded of tools, and again, this is two made-up products, increases from, let's call it 1,000 units to 1,700 units. Okay, so calculate question number 1, calculate cross-price elasticity, and question number 2, what is the relationship between outputs and outputs. Alright, so first of all, let's calculate our elasticity or cross-price elasticity. Some books like to use EAB, or other ones use EXY or YX, it doesn't matter. What we're trying to basically say is that there are two different goods being used here. It could be X and Y, it could be A and B. Alright, now the setup is basically the same. If you look at the formula, we're still doing quantity, percentage change in quantity at the top, and then we're doing percentage change in price on the bottom. Now remember to kind of label here to know which one you're going to be using as your price 1 and your price 2. So my first price is related to the first quantity that was given here, and the second price is related to the second quantity that I was given here. Alright, so we're going to do percentage change in price, sorry, percentage change in quantity. So I got to do 1,700 minus 1,000, then divide that by the average in quantity. So 1,700 plus 1,000, then you got that by 2. Alright, then I'm going to do my difference in price. So P2 minus P1, 14 minus 12. Alright, and then I'm going to do my averaging price. So I'm going to do 14 plus 12 divided by 2. All right, so as I mentioned before, remember, you don't want to be forcing all these stuff into your calculator. It's going to give you something wrong probably unless you're a bracket master. What we're going to do is we're going to be solving each one of those brackets separately. So this bracket right here is going to give me 700. Okay, this bracket right here should give me 1350. Let me verify it using my calculator real quick. Okay, it is 1350. All right, then we're gonna do this one here, so that gives us 2, and then this gives us 13. Okay, now we're gonna solve this top number here, 700 divided by 1350. So that gives us 0.5185. I like to carry, by the way, a few decimal spots if I can. And then we got to do 2 divided by 13. So 0.1538. Okay, and then now we solve this. So 0.5185 divided by 0.1538. And that gives me 3.37. And notice that the number is positive. Okay, so now is this elastic or inelastic? Or if you remember back on my explanation here on whether it's elastic or inelastic, what you need to do is you take the absolute value. So the absolute value of a positive number is the same number. So my absolute value is going to be 3.37. Okay, so absolute value of 3.37 is 3.37. Because that number is greater than 1, then we're going to say that this is elastic. Okay, so it's elastic. All right, so we calculated our cross price elasticity. Now the next one is, what is the relationship between caputs and tantalks? When you're doing cross price elasticity, one of the uses of it is that you can figure out whether these two products are related or not related. And what do we mean by related? Well, the products could be related in 3 basic ways. One is that there is no relationship. Another one is they could be substitutes. And another one is they could be complements. Remember, this is all related to the determinants. All right, complements. So these are related to the determinants of supply and demand. All right. Now, how do we know whether they're substitutes or complements? Now, in this particular case, notice that as the price of caputs went up, people bought more tantalks. That means that people were changing from buying caputs to buying tantalks. That means that these two products are substitutes. Notice that this number is positive at the end, and that's one way to tell whether the two products are substitutes. So if you calculate cross price elasticity and you end up with a positive number, you know that the two products are substitutes. And if you end up with a negative number at the end of here, then you know that the two products are complements. Okay? And again, I left that here on my PowerPoint. So using cross price elasticity, you can figure out if two products are substitutes, complements, or not related. All right, so let's move on to our next elasticity. Next elasticity is income elasticity of demand. In this case, we use the letter Y for income. So income elasticity of demand is a measure of the responsiveness of quantity demanded to changes in income. This is measured by the percentage change in quantity demanded divided by the percentage change in income. Now this is the midpoint formula for income elasticity. All right, so let's come up with an example for that. All right, so let's say your income increases from 20,000 a year to 30,000 a year. Then your demand for caputs declines from 20 units to let's call it 8 units. Question number 1, calculate income elasticity. Question number 2, are caputs considered normal goods or inferior goods? All right, so let's work on this problem. All right, so first of all, again, remember the formula. The setup of the formula is very much the same. Notice that we're still doing percentage change in quantity at the top, but then at the bottom, we're now using income because this is our income elasticity of demand. So we're doing a relationship between income changes and quantity changes. All right, so income elasticity in this particular case, let's kind of label the units like I said. So let's call it income 1, so Y1, and this is income 2. This is my first quantity, Q1, and this is my second quantity, Q2. So we're going to do the change in quantity first, so 8 minus 20, and then I'm going to divide that by the average in quantity, so I'm going to do 8 plus 20 divided by 2. Then I'm going to do my change in income, so that's 30,000 minus 20,000, and then I'm going to divide that by my average income, so 30,000 plus 20,000 divided by 2. All right, again, don't rush to the brackets, do it nice and slow. So first bracket up here is going to give me negative 12. This one's going to give me 14. Then we got 10,000. And we have over here 30,000 plus 20,000 divided by 2, so we're going to get 25,000. Okay, so now we're going to solve this right here. Just 12 divided by 14. Notice that it's negative, so I'm going to keep carrying that. Negative 0.857. Then I got 10,000 divided by 25,000. And I got 0.4 here. And that's going to be equal to negative 0.57 divided by 0.4. That's going to give me negative 2.14. All right, and that is my income elasticity. Now remember, to figure out whether it's elastic or inelastic, we got to take the absolute value. So absolute value of 2.14 is negative 2.14 is 2.14. Because this number is greater than 1, we're going to say that this is elastic. Okay? Alright, now the next question is, are kaput considered normal or are they considered inferior goods? Now, how do you know? Well, a lot of it has to do with your behavior. Normal goods are goods that you buy because you like it. So basically, as your income increases, you're going to buy more of them. But inferior goods are goods that you buy because you don't really like them. You just kind of sell them. So as your income goes up, you may buy less of them. So as your income goes up, you buy less of them. That's what an inferior good is. Now, how would the less show up? Well, it will show up over here as a negative number. Okay? So basically, if you do income elasticity and you end up with a positive number at the end, this is going to be a normal good. If you end up with a negative number, this is going to be an inferior good. Now we can take it a step farther, actually. If you end up with a positive number between 0 and 1, aka inelastic, then this is going to be a necessity as well. That end was terrible. Alright? So this is a necessity. Now, if you end up with a positive number, but that is greater than 1, then we're going to have an elastic relationship, and this is going to be a luxury. Or consider a luxury, at least, depending on your income behavior. Okay? So I wrote all that stuff down here on the PowerPoint. So if it's positive but less than 1, this good is normal and a necessity. If it's positive but greater than 1, then this is normal and a luxury. And if it's negative, then the product is inferior. Now, why is it important or interesting for business students or people in general to understand this? Well, there are goods that will perform well during bad times, just like there are goods that will perform well during good times. And a lot of it has to do with the behavior of people. So during bad times, because the relationship between your income and the good is a particular one, if your income level decreases, the relationship is negative, then as your income level decreases, you actually buy more inferior goods because the relationship is negative for inferior goods and positive for normal goods. So during bad times, and you think about bad times being recessions or times where people are losing income, one of the things that's going to happen is goods that are considered inferior will do better. So inferior good sales will go up. During good times, and again, those are times where income will be increasing, then normal good sales will go up. I'm missing that part. There we go. Normal good sales will go up. Alright, now I want you to think about the difference between like a new car, and I'm talking about, you have to think about exactly the same car, okay? So new car versus a used car. Now, if you compare the same car, new versus used, somebody would say, or most people would say, that the new one is the normal good, and the used one is the inferior good. Now, one of the things that you're going to expect, again, during bad times is that people buy more inferior products or used cars. During good times, people buy more normal products or new cars. All right, let's talk about elasticity of supply. Elasticity of supply is the responsiveness of quantity supply to a change in price. It's measured by dividing percentage change in quantity supply to percentage change in price. And this is the formula. Now, I don't really want to bother you, by the way, with another example because, again, it's exactly the same and we have already done 3. Okay, so I'll set up an example like this, then you end up with a change, and then you calculate it very much the same way. Okay, now elasticity of supply, it will give you instead a quantity supply, and it will give you a price. And that's how you calculate elasticity of supply relationship. And you can calculate any sort of elasticity by having 2 products and a change in behavior between one product and the other. Okay, so elasticity of supply can be calculated by following the midpoint formula. The way you figure out whether elasticity of supply is elastic, inelastic, or unit elastic is by following the same sort of process we did for the previous one. And one of the things that I definitely wanted to take some time right here in elasticity is I wanted to explain what are some of the things that create changes in elasticity in particular products on the supply side. So determinants of elasticity, the most important determinant of elasticity is really time. So short run is a sort of very short time period. Then we have what we call medium run and long run. All right, again, short run is kind of like, think about now and maybe within a few months. Medium run is within a few months to a year, and then long run is later, okay, whenever we can change capacity. So when it comes to products and the supply line, in the short run, the supply line tends to be highly inelastic. Okay, now I want you to think about something that the government was faced on in the last few months. Again, this being taped in May of 2020. So one of the problems that the US federal government has been facing in the last few months is the problem of COVID-19 testing. It's not like we don't have the technology to do the testing. The problem has to do with the production line. In other words, we don't have the factories set up to produce all the testing, nor do we have the facilities to process the testing. In the short run, I want you to think about a few weeks to a month. We cannot change all of these stuff. So all we can do is kind of like buy more of the product and try to process it through the same facility that we have. The more and more we figure out how to do that, the more and more elastic that supply becomes. And then there's going to be some point in the future, and I want you to think about, I don't know, call it a year from now, maybe 2 years from now, where the test, if required, is going to be pretty easy to get. So in other words, any sort of product that we have, when the product is new and we don't have a lot of it, normally it's highly inelastic. So if we need to produce a heck of a lot more, we're not going to be able to. So what is going to happen is the price is going to go up very quickly. And by the way, before we were even having this problem with COVID-19 testing, I want you to think about face masks. So one of these masks that was high on demand during this particular time is this quote-unquote N95 face masks. N95 face masks before COVID-19 used to sell for something like 7 cents each. And a month after the whole thing started, they're selling for $7 to $14 each. Why is that? Well, because we cannot produce more very quickly in the short run. So the more and more people demand it, the higher and higher the price goes very quickly. Now, I can almost guarantee you that as production increases, in other words, as more and more people decide to produce N95 Max or something similar to that, the supply line will be moving downwards. As a consequence of that, with the previous supply line, we had a fairly high price. With the new supply line, the price is dropping in the very long run in the future, what's going to happen is now the price will be pretty much back to normal. Okay? So every time you have a new product, because of the restricted production capacity, you're going to have a highly inelastic supply line. Well, as time goes by and we figure out how to produce it and how to multiply it and how to create more of it cheaper, you're going to notice that the supply line starts becoming flatter and flatter. Okay? And that's really one of the most important determinants of supply. Now, some products are going to be highly inelastic forever. Other products are going to be fairly elastic pretty much all the time because of how easy they are to produce or not produce. Okay? So, in any case, I hope you had a good time learning about elasticity, and I hope I clear up some of the issues with elasticity, how to calculate it, and how to do it. Thank you for joining Professor Choi in another lesson. Have a good time.